Hello friends, welcome back to another video on this channel. In today's video I will show you guys how I made this electromagnetic smartphone controlled crane. So the basic concept behind it is that there is two arms, and so there, as you can see, there is two corresponding servos connected to each arm. So when I use this app to which allows me to control each servo, as you can see, this slider controls the bottom servo and this one controls the top servo. So I will show you guys how I did this and how you can make one on your own. Now additionally, along with the arms, I also have two other things. So first I have this and the electromagnet itself. So basically this is connected onto a gear, as you can see, which is connected to this motor assembly. The way it works is whenever I press either of these two buttons, it basically receives a signal and it turns the entire crane assembly from one side to the other. And the way electromagnet works is basically, there is, as you can see, so this is just a very low power. In fact, if you are wondering, the power of this is 363 into 10 to the power minus 7 newtons. So that is very low power. The reason for that is, first, there is such a low cross sectional diameter here. So as you can see, this is very thin, so each and the area of each turn becomes less, and secondly, there is not that many turns, so this has 145 turns. And thus a third reason is the material. So normally you would have copper wire as the material you turn around the metal for making the electromagnet. However, here, as you can see, I have used solder. So the reason for that is I didn't have any thick copper wire on hand, and the only long single strand wire I had was of solder, so I had to use it. That significantly reduces its power. And the second reason is, obviously, there is the alloy used here. So normally you would have an iron rod here instead of an alloy, because the metallic conductivity of magnetic conductivity of iron is much more. So those are the reasons this is a very weak electromagnet. And obviously the third reason is it is connected to just a 12 volt 2 amp power supply, which is not a lot given the use case, but it's just a demonstrational purposes. So basically uh, the electromagnet is connected through two wires. It is going up there and coming back down. It is then coming here into this relay. So this relay then connects to that 12 volt 2 amp power supply, and the relay is further connected to the microcontroller here. So if you see right there, that's the microcontroller. So in this case I'm using the ESP8266 NodeMCU. So that is what allows us to establish a wireless communication. As you can see, there is a onboard Wi-Fi chip which allows us to connect to the internet, and it then connects to a secondary server which then connects it to the smartphone. So I will tell you in detail as to how to do all of this. So stay tuned and keep watching. But so the way the electromagnet works, as I have configured it, is whenever I press this button, so if I press this button on here, so this relay, it it will trigger the relay and it will turn on or off the electromagnet. So if you listen very carefully, you can hear a little click. That click is the relay switching. So let me show you a demonstration. So right now, as you can see, the relay is turned off. So now there is no current passing to the electromagnet. So as you can see, it is not attracting to this iron nail. Sorry, not this iron nail, this paper clip. So as you can see, it just falls when I touch it. It will just fall because the electromagnet is not magnetized yet. Now I will click on this button and I'll turn on the relay. So now the electricity is passing to the electromagnet, and so now it will become magnetized. So now when I hold this paper clip near it, as you can see, it will attract towards it. Now because it's so close to the ground, it's still touching to the ground. So if I pull on this slider and pick it up, and this one as well, so then as you can see, it's gone up. Now I can move the entire assembly towards one side. So let's say I take it from there and I move it somewhere over here. Then I can take it closer to the ground, so I can just use the servos on there, and I can move it close to the ground, and I can turn off the relay. So when I turn off the relay, it will take some time to de-electromagnetize as wait, so yeah, see, it will take some time to de-electromagnetize as obviously there is current flowing through it, and there is still a lot of turn, and the area of the wire is still quite a lot, so it still takes a little bit of time to de-electromagnetize, but it's not that much. And so if you're wondering, this metal ball and this big nut here, this is just for maintaining the center of gravity, as due to my way it's assembled, it's just comes off like that. So when it is towards the front, it will just fall towards the front if there is nothing helping it. So the center of gravity goes towards this, so too much towards the left, and then the whole thing will fall. So that's why we have this heavy weight so onto this side. So now in terms of the wiring and the more detailed part, so as you can see over here, I have a power bank. This power bank has two connections coming off. This one which is going directly onto the NodeMCU. So this is just for powering the microcontroller. The second is this, which then cuts off into the two wires and goes into the power rail of this breadboard here. So if I zoom in a bit, as you can see, connected to the breadboard is two more components. So over here I have a, so this chip here, this one, that is actually this is a L293D motor controller. So the ESP, it, although it's quite powerful, it doesn't have the capability to deliver a lot of voltage to the motors, because this, although it's a small motor, it just runs on regular 5 volt, it is still a very power consuming thing for a microcontroller. The microcontroller here, it can output a maximum of 3 volts. So this, because it's not even an Arduino, it only outputs a 3 volt current, and so it is nowhere near enough for running the motors. The reason it can control the servos are because of their gearing. So although servos are very powerful as well, well, not very powerful, they are quite powerful, but thanks to the gearing present on them, they can be relatively less powered, like they can consume relatively less power. So I will leave the wiring schematics for all of this. So for the microcontroller, so over here I have basically connected the pins from the servos, the L293D motor controller, and the relay over here. So I'll leave the pin outs for the relay and uh, the schematics for the microcontroller, and also the L293D, and as well as the servos, so you guys can connect it according to this. So I'll not give much tell you guys much about how I built this, because, well, as you can see, it's quite as well on, so it looks quite simple. I must say it is absolutely not simple figuring everything out, especially if you don't have some advanced tools like a 3D printer. It is not at all easy, and it takes a lot of time and effort to figure out how to build it. But anyways, once you have figured it out and made it yourself, so the basic concept of it is quite simple, so you guys can replicate something like that at home. I would recommend having at least two arms, and so two corresponding servos. I would if you guys are trying to make something like this a bit better, I would recommend having some kind of a spool here, so you can turn the a rope which connects it to this, so it can come up and down without moving the whole arm. And also, but I would recommend, instead of using servos for running the whole thing, using something like this, so it has much more power and it can turn a lot of weight. Because otherwise, if you use servos, you see, they don't have that much of power, so they are more overused for moving an arm like this instead of rotating something like this or this. So that's something which the servo can't do very efficiently. So I would recommend you use some kind of a motor solution rather than a servo. And for the electromagnet, well, I will basically, the electromagnet, the theory behind an electromagnet is quite simple. You just have a metal rod, you insulate it. So make sure, if you either use insulated wire, or you put some sort of insulating thing on the metal wire, metal rod, and remember, it cannot be of any metal that does not conduct magnets, that does is not magnetic. So if you use something like aluminum, it won't work, because this is effectively what becomes your magnet. So you have to use something that is magnetic. I would recommend using iron, but if you don't, you can use some magnetic alloy like this one. Then on top of it is insulated, so I have just put some clear tape over it so it's insulated. Then on top of that you can see I have the winding of the electromagnet. This is what the currents will pass through. So I would recommend, as I said, you use copper wire, so you don't want to overlap, or you don't want it to be thin copper wire, like you don't want several thin strands of copper wire going around it. That will cause problems and it won't work. You would want one thick strand of copper that goes around the whole thing, or you can use other materials like I have done here, but obviously the higher the resistance of the material, the lower the power it becomes. So from there you should use a some kind of a power supply, external power supply. So as you can see, I have this 12 volt 2 amp power supply connected to this extension cord here, which is then going on to a relay. So you have to use a relay for connecting it to the microcontroller. As I said, they are not sufficiently they cannot sufficiently handle such high voltage, high amperage current. So if you do end up connecting the 12 volt, it will most probably not work, if not fry up your microcontroller. So then I would recommend you power all of it to either of a good like a 5 volt plus battery system, not just off of one of these little four battery this four battery packs, because this will not last you very much and it will not provide sufficient current. So as you can see, this is a 700 milliamp hour battery, so this will on an average this lasts me for just about uh, 10 minutes or so of using it, whereas this power bank here, this is a 10,000 milliamp hour power bank, so this lasts me quite a long time. And in fact, for my entire time using this project and building it, this has not been charged, and as you can see, it's still at 82%. So that just goes to show how good these power supplies are, and also they provide quite a lot of high amperage power. So they can control not only they can not only control the both the microcontroller and this simultaneously, but the disruptive is less. So because the microcontroller uses micro USB as its connector, you can just use a regular micro USB connector and just connect it to the power bank. And for this I've just taken a old USB connector, just cut off its end and attached two of this pin connectors onto each end, so they can just simply go into the breadboard for relatively easy use of the for relatively making it easy. Now in the future I would like to add some kind of movement system. So I was thinking using something like a tank, like a remote control tanks base, or like a remote control cars base to the, but then there were some issues, so I will sort that out and maybe I'll do it in a second part. But for now I have just done this part, so let me show you guys the coding, and I will also leave the coding files down in the description. So let me go ahead and switch to my computer. Okay guys, as you guys can see, I have switched to the code now. And so over here, this is basically the thing that is running on the microcontroller and which tells it what to do. So so on this case, because we just can't really have a wire connected up to the smartphone with, or the tablet, which is then connecting it to the microcontroller, for it to understand, we need to have some kind of wireless protocol. So in this case, as I mentioned before, it's using Wi-Fi. So now in Wi-Fi, there it just there's no real way of communicating the two without having a third server. So in this case, the server is something known as Blynk. So I will tell you guys more on that later. So basically all you have to understand is this is defining it, the what it is, so the device name, your authentication token, and its template ID. So I will tell you guys how to get this on your own later, and all about this later on. But for now, this is basically, this is kind of like its name or its IP, because this don't really have an IP, it's kind of like its IP basically. Now down here, these are just the libraries that we're using. So this is for defining the Wi-Fi paths, this is just the Blynk servers, connecting it to Blynk, and this is just for controlling the servos. So down here we have defined the servos. So this first part is for the library, and this second one is actually the name. So I have named my first server as servo and my second server as servo1. You guys can name this something else, like for example you can name this something like arm and arm1, or lower arm and upper arm, or something like that, and you can add infinite more servers. So you can just copy this, paste it down here, and just add server 2 and make sure there's the this in the back. So that's basically this is defining it the servers. Now then over here, this is all your authentication. So you don't have to change anything about this, but this is where you put your Wi-Fi details. So obviously it needs internet. It can't really do anything with Wi-Fi. It needs a valid internet. So basically the way we give it the internet is by connecting it to an existing network. So this can be your mobile hotspot or your home Wi-Fi. So in my case, I have it connected to my Wi-Fi. So I would have my SSID. So the SSID is basically the name of your Wi-Fi network, which you will see, and the password is obviously the password of the network you used to connect it. Now I have removed them here because that is not something that I want to show. So you guys can put your own here. Same with these guys. I have removed this for now. Then down here, this is the part where the real magic happens. So in Blynk, there is something known as virtual pins. Virtual pins are kind of like digital pins, but they are a bit more. So digital pins only have they can only carry a current. So they can either turn on or off, or using ones and zeros basically. Virtual pins, on the other hand, they can carry any data. So they can carry something like a data for the servo. So they can also be dual side. So they can take data from the microcontroller and also send data to it. So here we are only using it for sending data to it. So I'll tell you guys how to define all these virtual pins and all of this later. But basically we are just writing the V0 to be the V0 to the slider. Basically I have set V0 and V1 to be the sliders, V2 and V3 being the turning right and left for the crane assembly, and V4 being the relay. So you guys can have infinite virtual pins like that for different sets. So over here now, as you can see, for these two it is a bit different from this. So here we are just, because it's a slider, there isn't exactly any on or off. We are just writing the data onto the servo. Same with servo 1. So if you had let's say 10 more servos, you would have 10 more virtual pins, and you would have the servo 10 more servo names here. This from this V2, V3 and V4, they are for buttons. So here we are stating that if the integer is equal to 1, then do this. So basically what this means is if the switch is turned on, you execute this, else execute this. So basically if this is 0, 0 stands for off and 1 stands for on. So if this is 0, you do this. So here I have set it to turn on, turn right, or keep everything low. So basically the way the L293D works is it has 4 connections for 2 separate motors. So in this case I only have 2 connected because I'm using only one motor. So the way it works is if you have one high and the second low, it will turn one direction or give it the power in one direction, and if the other sides are low, so for example here my digital pin 5 is high and 4 is low, so it turns left, and if my 4 were to be high and 5 were to be low, it will turn right. So as you can see here for V3 I have written if this is 1, you turn 5 low, 4 high. So I'll show you, I'll leave the schematics down below so you can implement this into your own creations. For this, it is basically my relay. So here it is just write pin number digital pin 0 high and digital pin 0 low. So basically the way a relay works is it's like it is basically it takes the smaller voltage. So if it sees that my digital pin 0 is high, it will then pass the current through it will pass the higher voltage current. So my relay here is actually a 320 volt relay, so it can take anything from anything from 0 volts to 320 volts, and it will not affect the microcontroller because it's just giving its 3 volt smaller signal. It's just a trigger. So that's why we trigger it high if the relay button is pressed and low if the button is off. Then down here we are just starting the serial monitor. So that's just to show if your microcontroller is connected to your computer rather than your power bank, which it's not going to be, but just in case we have the serial monitor. So then we are attaching the servos to digital pin 14 and digital pin 12. Now guys, one thing you have to remember is, so if I go, so my recording turned off. I was trying to say, if I open up this here, this is the schematics of the microcontroller and the L293D. So basically, as you can see, this is D0, but it's GPIO 16. So this is the number that we have to put into the coding, so the Arduino IDE. And you cannot put this because this is digital, so this is for it. But for the, since we are not using a proprietary ESP controller, we are using the Arduino IDE, which we are doing for convenience purposes anyways. So for this reason we have to put this number. So as you can see, it's not very arranged like you would see D1, D2, D3, D4. It is 16, 5, 4, 0, 2, 14, 12, 13, 15. So and 3 and 1. So so my pins are 14 and 12. Now you have to remember one thing. Your servo pins have to be analog pins, otherwise it causes quite a lot of problems. It might work on these two PWM pins, but it's not something that I would recommend, because these are more not really suited for that because of some reasons. They were acting highly unreliably in my testing. These four analog pins are what acted the most reliable in my testing, but you might get away with using any of these other pins. So now once I have connected to this, so as you can see, these are 14, 12, 13 and 15. So then comes the part for the L293D. So on this, as you can see, there are 8 pins on each side. Don't worry, this isn't going to be very complicated at all. So easily 4 pins are knocked off. So these 4 pins in the middle are ground. So you just straight up connect them to ground. Then this 2 pins, this one and this one. So the outer 2 pins for, so the third and the third and sixth pin on each side is for the motors. So output 1 and output 2. These are the two motors. So in this case I am only using this side and not this one due to the because I'm not having a second motor, but if you did, you can use that same thing. Then the second and the the second and the seventh pins are for the inputs. So you connect them to your microcontroller. So in my case, I have input 1 to PWM1 and input 2 to PWM2. So just don't really see this here. This this basically is for this is from a website I have taken. They are using it differently. That is for a different project. Don't really use that. Just make sure you connect these two to any pins here. You can use any pin. So you can use A0 and A1, but it's not necessary to use analog pins for this case, as it's just simply turning it this one high and this one low, or this one high, this one low, for deciding the direction of the motor. And if both of these are high or both of these are low, the motor will not spin at all. This remaining 4 pins are your positive pins. Now this pin, and this pin are for your regular 5 volt, and this one here, the VSS, the red one, this is where the voltage that will be fed into our motor. So this you can have it between 5 and 7 volts, because otherwise you would end up frying this. And this, it is written 36 volts, but do not at all try and put it into 36 volts. That is a terrible idea. It will instantly fry this. I don't know why they have written 36 volts here. Well, at least if not instantly, it will not work at all. You should I would recommend using 5 volts here and 5 volts here. So in my case, I just have all of this connected to the same 5 volt supply, because I'm not using something that is demanding more power than 5 volts. If your use is demanding more power than 5 volts, you can use something more higher voltage or higher amperage here. With that all out of the way, then we can go ahead and talk about this last 4 parts. So this last 6 lines. So this is just setting your pins as output pins, because I mean obviously the pins have to be output, not the servo pins. This is the pins for the motor controller and the relay, because the servo pins are not actually outputting. They are actually outputting a signal, not a voltage. Well, it is a voltage, but the way servos work are completely different. That doesn't work really by putting a voltage at all. That's not that simple. It works a bit more complicated way. So it is basically, these are just defining the pins to be outputs, and it's just setting it low. Then over here in void loop we just have it to run the Blynk servers. So now speaking of Blynk servers, let me show you how you can get the Blynk up. So basically you go into your web browser and you could just search blynk.io, sorry, not do, blynk.io. You just search blynk.io and this is the website you come in. So you just log in through your thing. I have already logged in. So over here this will show you all of your devices. Well, if you are a new you are doing something new, there will probably be none. So first thing you have to do is go ahead and go into this. So this is your template. So I have 2 templates for, because these are from my previous projects. This in fact is my current template now for this project. So what you have to do is go ahead and create a new template. Obviously over here you can give your name, specify what board you are using. So as we were using Esp8266, we specify Esp8266, and then you can use the you can specify the connection and then description, name, blah blah blah. Once you have clicked on done, so let's say name this test. So once we have done this, it will open up a blank template. So then over here you can just click save, and after editing the data, if you would like anything, then you can go into metadata, data streams, events, web drives, and mobile dashboard. These 2 are not required right now, not even this. So for now we will go into data streams and we will click on edit and add data streams. Sorry, not, so we will go over here and add data streams. You want to use virtual pins, and then you can add the data streams. So for example, for me I would have 2 servo data pins. So servo 1, I would set it and set this to integer, because we don't have a double data stream or a string data stream, because in our case it is just sending one-sided data. If it were to be receiving a data for something like a weather station or something like that, using something like a DHT11 sensor, which I have done before in my past. So if you are doing something like that, you might want to use double or string, but for now we'll use integers. Set this to set the minimum to 0 and maximum to 180 for the servos. However, for the buttons you want to have it set to 0 and 1. The reason you have set it to 180 here is because for the servo it isn't just 0 and 1, it is the duty cycle. So the 180 is the farthest it will go, and the 0 is the lowest it will go. So it just from in between is it decides the area, the position of the servo arm. And so doing this you can create as many as you like, and see over here it's you have infinite virtual pins. So you can select any one of these you'd like. So over here it's limiting it to 200 to 55 because it's a free account, but theoretically you have infinite virtual pins. So you can set it to vpin number whatever you would like. So I'll have it set it to 0, and then you have your first data stream. So like this you can create more data streams. So over here, okay, if I click on save, so you have your first data stream ready. So if I go over back into my original template, you see I have 2 data streams for servos, and then I have 3 button data pins. So as you can see, these are going to minimum 0, maximum 180, minimum 0, maximum 180, and 0 1 0 1 0 1. You don't need to set any decimals or default value, because that's not necessary for our case. It will automatically go to 0 because we have set it like that in the Arduino IDE, yes. And then over here, as you can see, all of these are integers. Now for adding a device, what you have to do, so over here as you can see I have 2 devices. Well, these are not exactly 2 devices. I personally prefer to have my codes separated out for each device. So instead of using the same device, I have created a different device just to have it be easy as just clicking this uploading the code and stuff, so I can then reuse this same microcontroller for other things easily. So that's why I would just click on new device. Because I have several devices already, so as you can see I can have a max of 2 devices. The reason for that is because, as you can see, this is a free account. So if you have that only I have 2 devices, so then it's just fine for you. Sorry, 0 devices, you can just create a new device. Now if I were to okay, one second, I'll just switch an account and go ahead and create a new account which has 0 devices onto it. Just give me 1 second. Okay guys, so I am back into the thing. So I have created another account. So on this, as you can see, there isn't a template, so this is perfect. So I can fully show you guys the steps. So you can name this whatever you like. So I'll just name it trial quickly, and then I'll set it to Esp8266 and type Wi-Fi. Done. I'll not create any data streams right now because I have showed you guys how to do that. So you can just click on save, and then over here you want to click a new device. So then you can do this and click on from template. You click this, you choose your template, and then device name you can specify, we'll leave it trial. You click create, and this is the data. So you remember how in the Arduino IDE I said this part is specific to your device? Well, this is where you get it. Okay, so if we go into device info, over here you can click to copy. You can just close this for now, and from this Arduino you can just do that. So now leave it like this for keeping it, but for like this you can then take this, and that's just specified. So from that you have added your new device, you have specified your data streams. Now what do you do? For now, all you have to do is go ahead and download the Blynk app on your phone. This is what connects it to your server. So now we have just connected the device to the Blynk servers. We need to connect the smartphone or the tablet to the Blynk servers as well, so to establish a connection. Now, as I said before, I am not hosting my own server for this purposes. For this, because it's not that convenient to always host a server, and also it's for recreating this project. It is going to be much easier using Blynk because it's already out there. Although it's still quite complicated and you might run into troubles. So if you do, please leave a comment down below. I will always help you out. But for now, all you have to do is download the Blynk app on your phone, and I will then show you what to do next. Okay, so let me just switch to my phone. Okay guys, once you have downloaded the Blynk app, this is what it should look like once you have signed into your account. Now as you can see, I have both my templates here as I showed before, because this is my original account, the one that I am using for controlling my Arduino, my ESP, and the one which is whose data is in my ESP. So now if you click on your template, you would now I have all this set up as I showed before, but you won't have this. So you want to click on this little wrench up here, and once you click on that, this is what you should see. So over here now, I normally would not have any of this. You just want to click on plus, and from here you can select all the things. So for us, what is important are these two, so the button and the slider. So you just want to click on the slider. It will add a new slider here. Now you can place it around the screen as you'd like, and once you have done, you can click your title. So for example, I have named mine servo 1 and servo 2, but I'll leave this now, and as this is optional. And then down here you have to select your data stream. You can select it. So over here you'll see all of your V pins. So servo 1, servo 2, direction 1, direction 2, electromagnet. So since we have set V0 and V1 to be 180, and for determining the servos, we have to set it to either V0 and V1. So we can select either of this. So if I click V1 here, then I would recommend you click this to be off, since this basically says that you will have to send value on release only. So if you release the slider, then only it will send the value, and not when you have clicked it, which is not some quite annoying and not something that I would recommend you guys doing, since the latency is already quite high, because it has to go through several different servers in order to connect to the ESP. Now once you have done that, you should see this. Okay, this is connected to my server 1 uh, slider. So if this would go, okay, the reason it's coming it is offline is because my ESP is turned off right now. I just turned it off because this is just showing you guys how it works. I already showed the demonstration previously. So basically, uh, these two are, since they are both connected onto the same virtual pins, as you can see, when I move this one, the top one also moves. And so if this would go, when I move the top one, the bottom one also moves, and this is completely separate on its own because this is V2. Same with this button. So if you had several different buttons, so let's say I added a new button here, and then I wanted to place it right there, then I could select a data stream. So for example, I said Electromagnet V4. Then you have several options here. Now you have the labels, so you can leave this to be on off, right, or you can set it to right, left, or something like that. I'll keep it to be on off. And then over up here you have the option for push or switch. So if you click on switch, it will become like the relay one. So basically it's doing this because they are both on the same, but basically it's like it, if you click it, it's switched on. If you click it off, it's switched off. Like it's like a normal switch, but if you click it on to be push, then it's different. So it holds. So if you are holding it, then only it is on, otherwise it's off. Like these ones, so if you are holding it, it's on, otherwise it's off. So like that you can set your this, and then over here you can just set the color of your text and font size. So I'll just delete this button and this servo because this is not something that I need. So like this you can set up your entire dashboard onto the Blynk app, and that is basically it. So that's how you connect it to your to your microcontroller, and then you can also control the other devices. And I will post more videos using this controller and the Blynk setup further, because this is my first time using my ESP. Until now, if you have noticed previously, I only used Arduinos, and they didn't have any wireless communication systems. So they were either just not communicating with other devices at all, or they were or in my case, when I made the racing wheel, it was just communicating with my computer but through a wired connection. This opens up a new opportunity as it is connected wirelessly. So yeah, with that, I hope you guys enjoyed this video, and please leave a like, subscribe to the channel, and share this video with as many people as you guys know. So and with that, I will be taking a leave. So I'll see you guys in the next video.